go, here we go. Here we go, here we go. Here we go, here we go. Here we go, here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go.
And welcome back to another episode of Containers from the Couch. We're back again here with a very special guest, a colleague of mine, which we work on the same team. Julian, please introduce yourself. Let us know who you are, what you're doing here, and I don't know, tell me what your favorite sport is, for example.
Wow. I'll have to think about that while I'm thinking about that. Yes, my name is Julian. I work on the same team as Maish. We work in the serverless applications team. I'm also a developer advocate. Historically, I've come more from the sort of serverless applications like Lambda and step functions and EventBridge. I do a lot of stuff with Lambda, and yeah, just love the sort of 2-bit part of our job where we do live shows like this and speak to people and teach people how to use the services, and then also speak to as many people as possible and, you know, get the product managers and work with them to develop the products and features so we can build as much the stuff that everybody wants. So yeah, I'm similar to Mesh. We do have a weekly live stream called Serverless Office Hours. So yeah, it feels a bit weird. I feel like one of those game shows where I'm now on the couch rather than the presenter. So slightly nervous, but I think we'll be okay.
Don't worry. I don't bite. It's fine. Don't worry. And what's your favorite sport?
Oh, my favorite sport. I'm not a big sort of massive sports fan in terms of doing teams, but I love the big sporting events. So the Olympics will come on, and the football will come on, and the rugby will come on, and those kind of things, and I can get fully involved. So yeah, I do those kind of things. Tiddlywinks is maybe really fun because I play that with the kids. Is that a sport?
Awesome.
I don't know.
I have no idea, but maybe.
It is now.
Okay. And my name is Maish Casing. I'm here a developer advocate as well in AWS with the ECS service team focusing on everything which is kind of serverless containers. And today we're going to be talking about containers in a slightly different context of containers in serverless and Lambda. So, Julian, firstly, is it possible to run a container in Lambda, yes or no?
Yes-ish. And this is one kind of... Yes, but I think the term container is interesting because that actually means quite a few different things to different people, and so it can sometimes confuse the issue. And a container can be a packaging format. That's a Docker file. It's an OCI kind of image, and that's what people understand as a container. A container can also be a deployment mechanism where you do a container and you can send them around the world on your laptop in the cloud and run those kind of things. And also some people think of containers as, when you containerize something, you build a microservice and do that kind of thing. And there's also sort of all the practice. So with Lambda, you can run Lambda.
That was a very long answer to say yes-ish. So
yeah.
Let's step back for a second and say, okay. So before we go into exactly how we actually do that, let's go back to, what is Lambda? How do our customers use it? What are they using it for?
So, in fact, why don't you bring up a slide and that'll maybe, visually just bring it up a bit. So Lambda is a serverless application where a Lambda function runs when an event fires. And that event can be anything. It can be, as it says here, a change in a data state. So that could be a database entry being updated, a file being uploaded to S3. It could also be an HTTP endpoint. So something hits an API and a Lambda function automatically runs. And that's the cool thing. Lambda just integrates with all these services and just automatically runs. It's as if you've got a Docker container that is sitting, waiting there. And as soon as an event comes in from all these things, it just sends an event to the Lambda function. You can run a Lambda function in fact, any language. We've got some things called managed runtimes like Node, Python, Java, Ruby, and .NET. But you can actually, there's a operating system only version of Lambda that you can run, and you can put any code in there as well. We've got people doing COBOL. I've done PowerShell. There's Erlang. There's PHP. There's anything like that. And then your Lambda function does work as you would in a container, and it will write to a database, read from an API, do anything, that kind of that. And so what we've sort of come out a few years ago is this sort of partly merging of the two worlds. And when I said yes-ish, is you can build a Lambda function as a container image. And that's why I said yes-ish, because some people think you can run any container in Lambda. That's not quite the case. Lambda is specific in the way it runs for very good reasons, and we're going to demo that and go into it. And so when I said yes-ish, you can build a Lambda function as a container image, which is awesome. But let's not think that you can run any container in Lambda because it's event-driven. So you wouldn't be running a big sort of monolithic application running a database, for example, in Lambda. That wouldn't make sense. So if we just sort of we spoke about the serverless applications, and then people go, well, why should I bother with Lambda? Because I'm running containers or I'm running things on EC2 instances and everything. And so what we think of Lambda is it's this cool service that just tries and abstracts all the infrastructure underneath you and helps with your operational support and gives you sort of this, you hand over AWS to do all the heavy lifting, to run this distributed systems, to do the operating system patching, to do the runtime patching. So when you use Lambda, you don't need to upgrade things, a whole bunch of things. Yes, your code, but all the underlying stuff just happens behind the scenes. It's high availability at the get-go. It's multi-AZ by the get-go, and so it just does a whole bunch of stuff. And often you've seen these kind of slides where we talk about from EC2 at the bottom through the various levels of sort of what you manage, and Lambda's up at the top of it. And if you want to think of the difference between if you're running ECS and Fargate, well, ECS, the control plane, is certainly serverless. With Fargate, it is serverless as well. You're not managing those individual instances. They're just happening behind the scenes. But with Fargate, you've got an operating system that you're running and you're managing, and you have some runtime code that you're running and managing. And so that's something that you've got to do. And so with Lambda, we take away a lot of that. Now, there are two actually ways that Lambda runs. One's with container images, which we're talking about today, and then one also where you actually just upload Lambda functions as zip files. And Lambda zip files is actually the really easy option because we can update the operating system underneath. We can update Node underneath and do all of that. If you run a container image, and we'll get into this, there's a little bit more you need to do, but you sort of get that flexibility that Lambda just does stuff. And then as the cool thing about Lambda is this application integrations, sort of 200 built-in integrations, and you can pull things from SQS or Kinesis or Kafka. You can batch things up. There's event routing, a retries. There's just a whole bunch of cool application architectures that are just literally built in. And the whole sort of mental model is just throw your code up into the cloud and we will run it at pretty much whatever scale you need to do it. And you don't have to worry about the scaling or the availability zones or any of that kind of things. That's what we will just look after for you. So when we're talking about the scaling, well, Lambda actually improved its scaling recently, and it wasn't slow beforehand. So previously, we had this sort of way where Lambda scaled, where Lambda scales, and when an event hits a Lambda function, and this could be an API, as I said, or a database update or that kind of thing, an instance of the Lambda function runs up. Actually, behind the scenes, it's a little tiny micro VM that literally takes milliseconds to run up. So it's really secure. It's not shared between any other function. It's not shared between any other customer, let alone any other kind of thing. So if you're sort of thinking in the container world, and you have containers on a single host or a single operating system, and some people are happy with that sort of abstraction, but some people think you are sharing containers with a single operating system underneath, and some people have concerns about that with sharing that operating system. Lambda is literally a micro VM per individual function that runs, absolutely nothing shared. So Lambda spins up, and you could have like 3,000 Lambda functions that could immediately run at the same time. So you've got 3,000 people hit your API. You don't have to do anything. Lambda will just run up for 3,000. And then it sort of had the scaling mechanism. Sort of every minute we could add a little bit more, and that's how it would get to. And so if you sort of had 10,000 requests coming in for your API, it would sort of take 12 minutes to get there. Like, not the end of the world, but we could obviously improve that. Now, this is from a standing start. If you had steady state workloads, this wouldn't be in play because Lambda is just adding more and more execute these micro VMs behind the scenes, and you're done. So this new scaling mechanism, instead of that 3,000 or whatever, we literally allow you to scale 1,000 every 10 seconds. So instead of taking 12 minutes, it takes 90 seconds to get up to 10,000 sustained requests. So nice. That is a vast amount of compute power that you can have in 90 seconds. Now, ECS and Fargate, you can get cold starts, really quickly with that. But it's going to, take some auto scaling. It's going to take some stuff to get up and running. Once it's up and running, those are big, beefy container images, so you can run a lot in them. But yeah, if you want really quick Lambda functions to run, lots of them really quickly, it's a really good thing. Lambda does have some other sort of constraints that it is. It's obviously got those languages it is in. A Lambda function can only run for 15 minutes. That's one of the big kind of things. And the point of that is Lambda functions are meant to be ephemeral. They're meant to be, sort of tasks that you can run really quickly. It's not a sort of long-running API or long-running data processing task that's going to go on for hours and hours and days. That's when you would really use ECS and Fargate. Now, some people change their applications. They split up the load that is going to run for days or hours, or more than 15 minutes, and they split them up into smaller chunks and run them on Lambda. And you can imagine with the scaling mechanism that you can get this sort of really awesome parallelization of any of your data crunching, and that can be really kind of quick.
So I have a quick question for you before we go on. Is the fact that if, for example, a customer knows that they're going to hit 10,000 requests at the first, that's the first, is there a way to like preempt that amount of saying I have 10,000, 100,000 requests ready to serve that kind of traffic?
Yes, you can. So it's a feature we got which is called provision concurrency, and that's basically pre-warming. So you say, we are doing containers on the couch. We are, okay, for my time, it's starting at 8 p.m. Of course, we are expecting like 3 million people, or, let's say 100,000 people are going to join because Mesh is awesome. This is going viral. People are going to be watching this. And so what you can say is use provision concurrency and use auto scaling with it as well, and say, I'm going to need 100,000 execution environments. Can you please set that up for me? Now, it's going to use this exact same scaling. So you sort of work back from 1,000 every 10 seconds and work out how long it's going to take. But you basically turn it on and it just pre-warms them all and gets ready. And then as soon as those, 100,000 requests, immediate requests come in, you just, they're ready to run and off you go. And obviously there's no, any future requests that come in, those actual micro VMs keep around. So it's not per invoke. They're going to run their little cold start process, set up a database connection, grab a secret, all that kind of thing. But then once up and running, they're going to stick around. So, there's a little sort of penalty to get things going. But once it's going, off in the races, and it's really quick.
Awesome. Thank you. Before we go to the next slide, I want to do something which I forgot in the beginning, was firstly to welcome everybody which is joining us in the chat. Please say hi. Let us know where you're joining from. If you have any questions, of course, please drop them in the chat. We'll try to get to them during the show. And back to you, Julian.
Cool. So we're talking about sort of why would you use Lambda? And, one of the things is also cost considerations. This is really, one of these serverless services that scales to 0. You don't pay anything if your Lambda function doesn't run. And, the cost is quite granular. Some people ask us to improve it, but it's like per millisecond. So this isn't sort of per hour or per minute or anything. It used to be per 100 milliseconds. Now it's per millisecond. So, you can't really get more granular. Once we get sort of picoseconds and that's a bit crazy. So really, a really good way that you can manage your costs, because if something's not running and you've got variable workloads during the day or during the week, if it's not running, it does nothing, and then it's going to ramp up. And then you basically allocate costs. You allocate memory to your function, and we'll show shortly. And you can have up to 10 gig of memory, and that's sort of 6 virtual CPUs. And that's the sort of performance lever you give. The more memory you allocate, the more oomph your function gets, the more you're going to pay. But that's sort of your control lever for that. And as I said before, you're not paying for any patching and any maintenance. That's just sort of part of the service. And so when we're talking about sort of Lambda and containers, I like to think of it as a sort of agility thing, because Lambda is a little bit different, and it's a service that is super flexible and super cool. But a lot of people who are building container images and they're using Docker or this kind of thing, it's like, this is something else I need to learn. And so this sort of marriage of containers and Lambda is really cool, because you can use your tooling, your Docker CLI, your CI/CD pipelines, your governance tools, your security scanning tools, and use all of that with Lambda and get this cool operational simplicity of Lambda. And so this sort of merging together of these things is this sort of nice heart, which I think makes it really good. And nice thing is dependency management. It's a Docker file. It's a standard Docker file. You just added your dependencies in the Docker file. You can install anything. You can do all of that in your Docker file. And so, as people use containers, the dependency management is a nice sort of thing that you can isolate in a Docker file, and you know exactly what your dependencies are. Dependencies are happening. And I mentioned before all about the tooling. If you're using ECR, using Docker Hub, tools that inspect the Docker files work all the same. That's a really cool benefit that builds this bridge. That once you learn a little bit about Lambda, you can use the stuff you already know. So we talked a bit about the sort of scaling, and we talked a bit, the size of Lambda functions. And Lambda functions can run can have up to 10 gig of memory. That's the biggest memory side. And there's a sort of proportional increase in CPU. Now, it's not quite linear over there because there's a sort of bit of a stepping thing that goes on. But basically, a Lambda function can be as small as 128 meg of RAM, and then up in 1 megabyte increments up to 10 gigs. So, I mean, 10 gig, 6 virtual CPUs, and can run for 15 minutes. You can actually do some pretty cool, either compute-intensive workloads or memory-intensive workloads to do that. And you also get 10 gig, up to 10 gig of temp space. So that's because it's ephemeral. Maybe you're going to store some stuff in the 10 gig space. Now, obviously, more than one core is about sort of 1.6 to 1.8 gig of memory. But, if you want to take advantage of more cores, as any app needs to be multi-threaded to take advantage of that. So you can't just sort of, normal computer and software architecture kind of stuff.
Yep.
Now, interestingly, one of the benefits of Lambda with Docker images, which is a bit counterintuitive, because I said before that Lambda is really cool, that it just patches all your stuff for you. But, as we know, when you build a Docker image, it is sort of frozen in time and it's immutable. You build your Docker image and it sort of stays there. And that's a really good thing, because some people don't want that automatic updating for Lambda, because they don't want just their crazy node dependencies off the internet or some Java update that can potentially break their functions and things like that. Now, there are other things that in the Lambda service that can help with that, but some people really like this immutability, that you create a Lambda function, you know exactly what's in there, you put it through your CI/CD pipelines, and nothing's got to, modify it. You test it on your desktop, you can ship it anywhere in the world, and you know that nothing's going to be patched and updated in the meantime. So that is cool, but also means you are taking on a little bit of an admin step, because now if node is updated, or you've got a dependency that's updated, or the SDK is updated, you've got to go and rebuild that container image. So for people in the container world, that's what they do. That's what they do day in and day out. They know they need to do that. But people from Lambda are like, oh, I've got to update that. So something to think about, and you get the benefit of this immutability with Docker images, but it's something you need to look after. So in terms of flexibility, one of the cool things with Lambda support is previously, when you build zip archive functions for Lambda, it basically runs on Amazon Linux 2023, and that's all fine. Lots of people use Amazon Linux 2023, and they like that. But some other people go, well, hang on, I use Ubuntu, I use Alpine, I use some kind of other kind of distro, and so also now with having container image support with Lambda, you can actually use any kind of distro. And this also gives you a bit of flexibility and simplicity, because it means a function that you build for Lambda is now actually able to run on, Fargate, EKS, ECS, even on-prem in a hybrid cloud. And so you can also build these Lambda container images that are a bit more portable, and you can use them around. Now, Lambda does things a little differently in the way I said it manages events, but ultimately you could still have the same code, and whether you've got something coming via an ALB, for example, into ECS, or via an event coming into a Lambda function, that's just looking at some parameters on an input object. And yeah, so you can have these cool portable Lambda functions, because it's a Docker image that you can move around. So anything that's OCI, that's all it's going to do. As I mentioned over here, Alpine or Debian or any kind of image, and that can be up to 10 gig. Because a normal Lambda function, when I say normal, a Lambda function that's with a zip archive is maxed out at 250 meg. So 250 meg, that's going to happen. That's now up to 10 gig. The base images, as I mentioned, Lambda actually provides base images for all of these managed runtimes. So you don't have to package up Node and .NET, Ruby, and all these kind of things yourself. Lambda provides it them themselves. And you can see here in the Docker file, and this is old Docker file. I hadn't updated it, Node.js 12. And this is just going to grab the Node.js 12 Docker file. And that's got all the Lambda stuff that is built in. And so you don't need to install any other kind of stuff to make it work with Lambda. And it's these two components that do it. I'm not going to get into too much detail, but basically there's a client within the Docker file that gets installed. And this is the thing that when an event object comes in, it's going to sort of parse it and change it into the Lambda format. And when you send the response back out, it's going to send that off to the Lambda service. So, it's just like a sort of client. It's actually a very simple client that just does a loop to an API, and that's it. And then also there's a runtime interface emulator, and this is a way that you can actually test Lambda functions with Docker locally, and it emulates the Lambda service. And also that's just part of the image. So it's just to let you know that there are these things that the Lambda base image includes, stuff you don't just have to you don't just have to manage that on your behalf. So before I want to say let's get it into action, do we have any questions or any kind of things, because I've been rambling?
So there was one question which came in, which is slightly more general, the fact of what is the best way to handle secrets and credentials when you're using Lambda?
Yeah, definitely. So as with lots of other AWS services, you can store secrets in parameter store, you can store it in secrets manager, you can use HashiCorp Vault or anything. And what you generally do is there's sort of, when I was talking about the initialization process of Lambda, that's where you go and you just go and grab that secret. You then use that secret in Lambda we've pulled from it. And then because subsequent invokes use that micro VM and reuse it, that secret is there and available for you. Now, for people using ECS, ECS provides the secrets or can provide the secrets as part of an environment variable. Lambda doesn't quite do that. Well, doesn't do that at the moment. It is something we are looking at and trying to work out what happens. So yes, you basically grab the secret from any kind of service, and then you can use it within your Lambda function. There is some other additional functionality because secrets is one kind of things, but some people use feature flags. So you can imagine feature flags maybe change during your invocation of your Lambda function. This could be to turn up debugging, or it can be some feature flag for a code path to, do some whatever kind of different kind of thing. And there are ways that you can use something like app config, or you can use launch darkly or some other kind of feature flagging services. And even while the Lambda function's running, there's another process that can go and can grab that updated value and send it onto your Lambda function. And so that's another way that you can do it. So not quite secrets, but just another way that you can dynamically update values in your function.
And for the love of all things holy and wonderful and dear to your heart, never, ever, 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 ever store your secrets or credentials in your code. So
yeah, definitely, yeah.
But yeah.
Definitely let alone in your GitHub repos. So yeah, we've got these great services, and off you go. Sure, there was something in the back of my mind when the question happened, and I've forgotten. But I'm sure it'll.
So what is this emulator? You say there's a client and an emulator. What is the client? What does the emulator do?
Yeah, so the emulator pretends to be the Lambda service. So this allows you to use it for testing services. So we're going to actually try that out now and see how you can locally test Lambda. And so it just pretends to be the Lambda service, and cool. So you can test things locally, so you don't have to install any kind of stuff. And then, the client is what is actually installed, and that runs then in the production service when you're running on Lambda, and that's just the one that interfaces between your code and the Lambda service.
And it says we have an option of that for each managed runtimes. In other words, all the ones which we support, and if somebody has their own container, and
exactly,
is there a way to compile it for themselves?
Yes,
or they need to go?
Yeah, and it's all open sourced. I mean, it's a bit in blue there, but you can go, github.com, AWS Lambda, Node.js runtime interface client, screenshot that, and you can grab that. So, there is one for all of the managed runtimes, and there's also that open source, the operating system only custom runtime also has it. It's actually quite simple. So, but you can use that. And then, so these are all the managed runtimes, and you can just go and grab that, and that is built in. So should we make anybody interested in actually seeing how this all sort of works?
Of course.
I think so. So we're on containers from the this is going to be fun because I'm on another screen, so I'm typing over there and looking over there. So it's weird being the guest and not being the host. I'm all sort of So this is, funny enough, a Docker file. Anybody on containers from the couch seen a Docker file? So this Docker file is really simple. I've got a sort of simple app. It is going to, when it's going to build my application, it is going to pull the Node.js managed runtime from Lambda. It's got all that stuff in it. It's going to copy my application code, and it's going to copy my package.json, which has my dependencies. npm install, it's going to install those dependencies. And then it's going to do the CMD. And this is where you are telling the Lambda service that when the function invokes, this is where in the code you're going to go. So I have my app.js, and this is my application. It's using a third-party library called Axios, and so that is what I'm going to install as my dependency, which will be in my package.json. So if you're a Node developer, this could be Python, this could be Java, this could be any kind of other runtime, that kind of thing. And so I'm just going to check my IP, and then this is when we're in the Docker file, and we said we're going to go into the app, which is the app.js folder, and we're going to use the Lambda handler function, and this is the Lambda handler function. And what the Lambda function does is it passes automatically in an event object. So if you are reacting to something coming from S3, for example, this will be the location of the S3 object. If you are reading something from Kafka, this will be a batch of records from Kafka. If you are behind an API gateway, something like that, on ALB, it will be all the information that's coming from that API, the path parameters, the, any headers and that kind of thing. That just gets populated in the event object, and you can use that in your code. And then Lambda also adds a context object, and this is just information about the runtime environment, the runtime, the log group, the time remaining, the memory configured, and that kind of stuff, which you can also use in your code. So I've got a simple function over here. I am going to get my IP address. I'm going to log the event, just stick it in the logs, and then I'm going to return just hello world, and with use a JSON object, hello world, and that data. Do the catch, and that's it. And I'm going to return the response. So anyone who's done any programming, other than just understanding that I've got an event object, a context object, and this is basically Lambda. So I have a Docker file, and I have my package.sh and everything. I'm just going to build this Docker file. So at the moment, I'm not using any other serverless tooling. Do you know what? I haven't installed Docker. That would probably help with this whole kind of thing. Containers from the couch, you've got Docker running. So, so this is just going to use the normal Docker run, and it is going to take 1 or 2 seconds. And we are live streaming, so the CPU is sort of chewing up.
Doing it live is always.
So we'll just wait.
That's what we love to do.
Docker to come out. Exactly. You can see we're live. We're not doing this all. So yeah, I do have another screen. You can see here the Docker engine is starting, so we'll get there once it's done. Yeah, so at the moment, and this is when I was talking about using your familiar tooling. It's just stuff is nothing specific you have to know about serverless. So Docker engine is still whirring. I'm turning my head around because that's what it's doing. And basically, once I'm it's going to tell me I will turn the hamster in the wheel a little bit quicker. Hopefully that's going to work. Oh, it says something loading image. Maybe we've got luck.
There we go.
No such file or directory because I'm not in the Hello World folder. And I'll do my Docker build. And it's going to build. So, as with all Docker files, I'm building a Docker image called Container from the Couch Lambda 1. The latest version over here, and I've pre-built this before because I didn't want to have to download probably the 150 meg that this Lambda based runtime has come from. So, but if you did it by yourself, it's not going to take much long. But on a stream, you don't really need to be listening for that. So what I can actually do is I can actually run this. I can then run this Docker image. I'm doing another terminal, and I'll explain why. And so this Docker image is running. So I've got my application running, and it's just sitting there waiting for me to invoke it. So that's got that emulator that is already built in, and I can then go back and I can just do a curl, and I can. If I could copy and paste, that would also help, because with my typing, getting all of this correct would be terribly wrong. There I've got hello world. So this is now as if I was a client on the internet. It could be a web app, it could be an internal microservice. I've spoken to that Lambda function, and I've got hello world with the IP address, and basically this code has run. Excellent. So I've just done everything. So remember when you're talking about that immutability. Well, what happens if I need to then change my function? Well, obviously what I've got to go and do is I've got to change my code. So maybe in the event object, I've decided, well, I'm actually going to be kind, and I'm going to talk about somebody's name, and I'm going to do that. So what I would need to do, as with all Docker stuff, I'm going to rebuild my Docker function, my Docker image, and then I'm going to rerun that again. So it's doing the install, exporting it, But I mean, my PC is slightly slow because I'm doing the live stream, but I mean, that's pretty quick. It's, as if you're normally building a Docker function. I'm going to cancel that. I'm just going to run the Docker run again. And then what I'm going to do is I'm going to post that. And then this time I'm just sending, normal curl with a JSON object going named Julian. And that's going to come back, hello, Julian, with a location over there because I've now changed it to the event.name. So that's coming via the event with event.name, and I'm able to use that in my code. Cool. So another cool thing you can actually do is you can actually run Docker locally to sort of explore a bit how Lambda works. So I'm looking down, my mouse has just come up and said the battery is running. Typical, we're on a live stream and you got to find a code.
Yep, Julian kind of dropped. So wait 1 second till he comes back, I hope. So in the meantime, while we're waiting for Julian to join us again, I would like to first apologize for the technical difficulties. And secondly, to welcome everybody who's joining the stream. We're already here with Julian Wood, which will hopefully will join us very soon. And he was teaching us a little bit of containers in AWS Lambda. And let's just hope that we get him back. This hasn't happened before. And of course, this is what happens when we go on live. So in the meantime, while we're waiting for Julian, anybody have other questions that you would like to ask in the chat so we can pass the time till he comes back? While waiting for that. So what I do want to actually also emphasize over here is the fact that it is a lot of customers come to us. Here's Julian again. Hold on a second. And you're back.
Don't know what happened there.
Yeah, Julian's back. So I was just going to say the fact is a lot of customers come to ask us, when should I use Lambda? When should I use ECS? Or should I choose one over the other? And the answer that I personally like to tell is use them both when the use case matches what you're trying to do. So if you have a use case which will be suitable for Lambda, use Lambda. When you want to use ECS, use ECS. If you want to mix and match between the two of them, always find the use case which is good for your specific requirements and your application and your business model. That is what you should use, not one or the other based on somebody else's popularity. Yeah,
no, definitely. And use the thing you're comfortable with. If you're super comfortable with ECS and Fargate and that's going to work for it, that's not a problem for me. I'm not going to be a serverless purist. But if you've got code that can run in a managed runtime, can run for less than 15 minutes, and can use Lambda's event object, Lambda is a great simple way to run your code in the cloud. As long as you need longer than 15 minutes and you can't break it up. Maybe you specifically also if you're using not necessarily Fargate, but if you need GPU support or those kind of things, obviously heading towards ECS is going to give you some of that extra hardware stuff. So we were talking about
the stream, Kevion. Good to see you.
Nice to see you. We're back. So another thing you can actually run, I can run this Docker image just via an interactive login. So this is cool because some people don't sort of understand how Lambda works, and I can do an ls, and I'm literally now within this Lambda function, and the app.js is what I copied over there. This is the node modules that were installed. So this had Axios and the follow request. I mean, I can actually from in here do npm install. Say, how about AWS SDK?
It's an install, not an uninstall, but.
Oh, jeepers, npm install.
Yeah, that's why we say doing it live is always fun.
And so this is installing the AWS SDK. So this is something that actually people often don't realize. They think, oh, Lambda's a sort of black box. I'm going to run my code in it and I don't understand it. But here I'm using Docker. I can literally locally SSH into Docker run
your Lambda function
inside within my Lambda function. And here I can't run this in the cloud this way, but I can explore, I can install things, I can edit code, I can do a whole bunch of kind of things. Some people get cool and advanced where they then map volumes from within the Lambda function to the local file system. So I could technically be in VS Code for this folder and have that mapped into the Lambda function, and people can do that and they can play around. So that's, for a bit more advanced people with Docker, that's also a cool kind of thing. But let's exit out of that. So this is all local, but obviously we want to run things in the cloud. So what I need to do is, the way this works is Lambda basically, let me see, did I actually explain that? I may have a slide to do that. Nah, we'll explain it in a better way. So basically what happens is, you create a Docker image locally as you do, and then you upload it to a repository. Now, Lambda currently supports ECR, so Elastic Container Registry, with all its features and its scanning and its replication and all the cool kind of stuff that does. So to get this into a cloud, I am going to then log into ECR. So standard, normal, AWS ECR get login. I'm going to pipe that through to my local Docker daemon, and that's going to do kind of thing. So I've logged in. And then what I need to do on ECR is create a repository. Now, I think I actually created this before, so it's going to bomb out and say it already exists, but I've created a repository. So then all I'm going to do is I'm going to push this local image up to my repository. Now, I already pushed this before because it turns into about sort of 200 meg, and that's just going to be boring to watch over an internet connection. So this has pushed the layer, but I have made a change to the code, and you can see that was really quick because of the way the Docker images are done. Obviously, you want to put your more changing Docker layers further down in the Docker file, and so the rest is going to be cached, and that's going to really be simple. So I now have a Docker image in ECR, and it's ready to run and ready to build a Lambda function from. Now, this is one of the differences between zip Lambda functions and Docker Lambda functions, is you then create this Lambda function from the container image. So I am going to then specify this long command, which I'll walk through. So I'm going to create a function in my region. I'm going to give it a name. I'm going to say the package type is image, and then I'm going to say, you know where the code is? The code is from that ECR repository where I've just loaded something up. And then something else I've got to do is I've got to give Lambda an execution role. And so I have a basic execution role, which I ran over here. And this is just the permission to run Lambda. So yeah, I mean, you could go to the IAM console and create this role. Resource config, because obviously I actually have pre-created that as well. So I could, why don't we create another function? Lambda create function name CT.
2.
Containers from the cloud. 2. Oh, what's going on? Yeah. Hello. It's a bit weird. What's going on? DKC 2. So that's going to go off, and that is going to build the Lambda function. Now, behind the hood, there's actually some cool stuff that's going on. You can see that this resource is creating. And if I was to immediately go and invoke this function, let's see if I can catch it in time, because it's actually going to error. What was it? Number 2, we did it. And this is actually going to error out, hopefully. No, I was too quick. So basically, behind the scenes, Lambda is going to build that image from the container, build that image from ECR. But behind the scenes, it is going to do some amazing optimization of that image. Because one of the things with Lambda, where you saw that scaling and a 10 gig function, that sounds insane. You're going to have these crazy cold starts because every time a Lambda function runs, you're going to have to download like up to 10 gig of code. Like that's going to take forever. So what Lambda really cleverly does behind the scenes is it optimizes that image by caching things. Now, if we are and the cool thing is that it actually very securely, and too much detail for today, and there's some links I'll find and put that, but we've got this awesome secure scaling caching technology, which is able to cache things across multiple functions, across multiple customers without sharing any code. So think of it. When you have a Lambda function or you have a container image, it may be configured for 10 gig, but you're never going to load all of 10 gig in the meantime. So I know you've got seekable OCI for Fargate images. Think of it as a similar kind of concept that you're going to be able, you only need to load the image, part of the image that you're actually going to use. But if you've also used a managed runtime, Node.js, Python, all those kind of things, those are already going to be cached as part of the service because other customers are already using those runtimes. So actually the diff is literally just going to be probably your function code, which is going to be, you know, a few, maybe 100 lines of code. Really minuscule. So that's going to be really quick. So people are freaking out about Lambda functions, 10 gig cold start is going to be horrific. No, you're going to get this awesome performance as fast as zip, even faster at some kind of things for the bigger image sizes. So,
and I assume you're doing that, of course, with only that will mostly be with the managed runtimes. I'm assuming if you have your own runtime that you build on your own, it could take longer.
Correct, but the first time you're going to invoke it, it may take longer, but then that's going to populate the cache. So the next time you're going to run it, it's already going to be in the cache, and you're going to be able to take advantage of that. So, you know, many people, they're even running a function once through their CI/CD pipeline if they are using a base image, and maybe it's got a machine learning model, or they've got, you know, Python pandas or some kind of thing that could be big. You know, literally running it through their CI/CD pipeline is already pre-warming that cache, and so when production comes, you're going to be there. So we have our function code. So what I'm going to do is I'm going to run it, and I'm going to, so this is now running the Lambda function in the cloud. I've given it a payload with the name of Julian, and that's executed all correctly. And basically I've just dumped out the results, invoke results, and I can catch, oops. hit invoke result, and there we go. This is actually running in the cloud. It's running remotely. Hello, Julian, because it's got my code name and the IP address, which would actually be different. 3237
from 51 something.
Yeah, exactly, something like that. So someone's happy to track me down with my IP address you saw over there. And that's it. So I've literally invoked this function in the cloud. Now I can go into the Lambda console. I can view this function. I can go and test it there. I can then hook it up to API Gateway or Kafka or any of these kind of things, and I can run that. So this is the simple way I've used all of the local tooling. I've only used Docker. I've used the AWS CLI sort of sparingly, literally just to create the Lambda function and then to invoke the Lambda function. But there were a few commands I had to do, and I'm now manually creating a Lambda function from a Docker file. I haven't really got infrastructure as code. Not necessarily the best practices. So I'm going to show you a way that we can use AWS SAM, which is the serverless application model. And this is a way to define infrastructure as code, and you can use all CloudFormation resources and allows me to build Lambda functions. Now, it's not the only way. If you're a fan of the CDK, or you use Terraform, or you use Pulumi, or any of these infrastructure as code tools, this will work in the same kind of way. So you can build your Lambda functions as Docker images from infrastructure as code. So I have a SAM template over here, and this template is really simple. If you know CloudFormation, it's pretty similar. SAM just allows us to abstract some kind of things, makes it a little bit simple. So if I'm connecting API Gateway or Kafka, I don't have to build a whole big API Gateway resource. I can just specify the event. I haven't got it here for simplicity, but you can do that. All I'm specifying, I've got an image package type here. Architectures, I can use x86. I can also use Graviton, so I can use Graviton 2 as a container image. And all I'm saying is this is what I want my tag to be. My Docker context is where my Docker file is and what the name of the Docker file is. Boosh. So what I'm going to do is I'm going to then use a different command. Instead of Docker build, I'm going to use SAM build. And this is then going to sort of do that Docker build process in the background. And to be honest, it's actually using Docker underneath the hood. And so it's just going to be able to build that application. So I need to go up another folder because I'm not paying attention. So if you think of Docker build, this is just a quick abstraction that it's going to do. There are a whole bunch of other functionality that you can use. A cool thing with SAM build is you can actually use another container image to build it. So you don't need to have Python node, all the kind of stuff installed. You could use something different and just use a different container as your build container, which is pretty cool. So again, I haven't deployed this function yet. Yes, Mesh.
So I had one. There was a question which came in before we continue with the building. There was Juan David Sanchez had a question about the fact, and I'll pop it on screen and clarify. So it's not AWS. Is Lambda with containers suitable for network-intensive workloads? For example, like video transcoding. Yeah. Is this something you can do in Lambda?
Yeah. You can definitely do that in Lambda. In fact, that is super useful for two reasons. Because you can scale them out. So you can run, some people, if your image transcoding can happen in under 15 minutes, Lambda is going to be perfect for that. And even if it can't happen in under 15 minutes, a lot of people split them up. So you can run parallel workloads in Lambda to do that. So you can think of an example of like even a 2 or 3 hour movie, for example. Some people use, what's the image manipulation library? My brain is
FFmpeg.
FFmpeg. So you can use FFmpeg and you can point to a particular part in the file. And so what people do is they look at the size of the file, divide it by the FFmpeg to do it in even 30 seconds. And they could run 1,000 concurrent Lambda functions to crunch through that file, transcode it, put it somewhere, and then assemble it afterwards. So yes, you can. The question was actually about network throughput. There are some limits to network throughput, but I mean, the more memory and CPU, the more memory you configure for your function, it gives you more network as well. And I've never sort of really come across someone who says, the networking throughput has been the issue. You can imagine there's a lot of S3 processing that happens in Lambda. So people upload, 10 gig files into S3, download that into the Lambda function and do some processing with that as well. Not that I've heard, not to say that that doesn't happen, but I think the networking is pretty good.
And of course, keeping everything local to your specific region will make things a lot easier without cross-region traffic as well, also from cost perspective.
Yeah.
There was one other question which we had from Ben O'Held, which was, what is the benefit of using a Docker container over standard JSON Python code? And I think you
Is
answered this before. There's
yeah.
not really the benefit. It's more the fact of what you're comfortable with.
Yeah, and the standard, I mean, you've got to run your Python and JavaScript code in something. So it's going to be in an EC2 instance or even, in an ECR image. So is the question about where you're going to run your code or why specifically Lambda? And
I think the question would be, what is the benefit of running using a Docker container? In other words, what you showed today to running native Lambda functions.
Yes. Well, because if you from the container world, that's going to be familiar to you. And also it's going to be a 10 gig function. So if you need a big function, it's going to be 10 gig. If anything under 250 meg, you've then got this choice between using a zip function or a container function, and then that choice is up to you. So maybe actually, if you're willing to learn a little bit more about Lambda and how the packaging format works, just use a zip Lambda function, because also that operating system is going to be, and the runtime is going to be managed automatically for you and upgraded automatically. So, I mean, we've even got functions that have literally been running for years and never need to be updated. The code is, simple enough that there's not a security issue in a dependency. And literally these Lambda functions have been running for years, never have been touched. And they, the operating system is just upgraded and they just do their thing. Yeah. So we were talking about SAM, and we did the SAM build. And also what I can do is I can use the SAM local invoke, and I can pass that an event object. What did I do? I picked an event object that was the name of the Julian. So actually, this is also using Docker behind the scenes. I think there may be some output. No. So this is using Docker behind the scenes, and this is going to build an image, and I can locally invoke this function. So in a way, this is simply the similar way I was doing when I was using Docker run, and then I was using curl to get into that function. But you can see this sort of follows the Lambda event-driven model, where I'm not doing Docker run and then curling to get to sort of do that input and output. It's just doing it, and it's obviously got an issue in my code. It's not behaving with it hasn't seen the event object. It just says my name is now undefined, which is a bit rude of it. But
the event didn't give the name, I assume.
No, exactly. I wasn't very polite, and you can see the IP addresses locally. But so now I can test my functions locally. I'm not having to run that Docker endpoint to do that. So one kind of thing. But the cool thing now also about SAM is there is a thing called SAM deploy, and not over there. And SAM deploy then can actually package up your Lambda function, can automatically create that ECR repository, and oops, did I do the guided? Yes, I did do the guided. So so Sam is going to do that create that repository automatically, and you can see over there, this is CloudFormation, give it a stack, a region, don't allow Sam to create a role, disable rollback, configuration file, just a few kind of settings that it's going to do. But that's just going to do this. It's going to do that Docker tag. It is going to do that, create the repository. It's going to do the Docker push, and then it's going to build that Lambda function from that image artifact. So in a way, one command, you don't have to then run all those Docker kind of commands, and this is pretty cool. This is also cool because SAM is going to allow you to use all CloudFormation resources. So maybe you have something that connects to a VPC, or you are building a Kinesis stream, or you're also building ECR things and all this kind of things. So you can build a whole bunch of resources within that infrastructure's code file and deploy them in addition to just using your Lambda function. So instead of having to manage your Lambda function individually, Docker push, ECR, and all that kind of thing, this is all cool. Now, so I called this a different name. So you can see we obviously live here. Is this the SAM deploy?
Mm-hmm.
Something's going funny with my, okay. I do my deploy. SAM. It's weird, it's not appearing on the screen. Basically, I didn't do the latest image tag. So you can see over here, CTFC, I didn't do the latest image tag. I think that was my mistake. Anyway, this has been pre-deployed, so we'll just pretend to do that kind of thing. So
awesome.
yeah, I could go to the Lambda console now, and I will have a new function, and that is in the console, and that's all been kind of built. And then what I can also do is I can also do now a SAM remote invoke, which is what I was doing before when I was doing the AWS CLI command. Something really funky over there. So this is SAM remote invoke. And this is looking then at the stack name, which is in my CloudFormation template, sending off of the name, and this is going to then invoke the function in the cloud and come back with the results. Hopefully, it's got to work out what the function name is. It's a little bit slow, but off it's going to go there. So there we go, and it's now come back with a hello Julian. So this has obviously been a little bit better, and you can see the IP address I'm running in the cloud. Now, you also, if you had multiple functions in this infrastructure's code template, you just select the function, and off you can go. And so this is a way that you can do things. But now another cool thing you can do is, I still have this Docker daemon running. Maybe that's why it was messing up beforehand. What I can also do is another kind of thing is you want to run things in the cloud, but you want to get the logs locally. And this is sort of something to think about where developers are working on their local IDE, and they want to do lots of stuff in their IDE. And Docker is, of course, awesome for that because you can create everything. It's quick to iterate and everything. But you're often using cloud resources. You maybe have an RDS database or DynamoDB or interacting with EventBridge or any other kind of service in the cloud. And you can't mock you can try to mock and emulate all of those locally, but it's hard. You've now got to manage other kind of stacks. It's going to be
you
tough
shouldn't do that. No.
Yeah, and for some kind of things you can. So if you're mocking like the event object I was passing in, that's really easy to mock in. There's some other kind of services which have sort of really easy mocking that you can do. Sure, off you go. I've got an API gateway that I can pretend to run locally. That's all going to be really quick. But if I'm writing to RDS or I'm writing to some other kind of service, like you're not testing your IAM permissions, you're not testing your scaling, you're checking on your code. So I say, unit test your code locally or that kind of thing. As soon as you progress beyond that and that's right, you actually want to run things in the cloud. So this idea is that you also want to sit in your local terminal. You don't want to also context switch and have to jump to the Lambda console or to the CloudWatch console to do kind of things. So one thing you can do over here is you can, not the Docker run, it would be, what was I doing? SAM, I was in the SAM world, SAM logs, that's the stack name. And I can basically tail the logs for this Lambda function. So what this is going to do is it's basically not going to talk to Lambda, it's going to talk to CloudWatch logs and say for this Lambda log stream, this CloudWatch log stream, brilliant. So yeah, we are having fun here today. If I scroll up between
interesting.
Is that my stack name? Yeah, that's a nice Python error. Docker run, what is the it's just Docker. It's not Docker run, it's SAM logs. Stack name CTFC Lambda 3 tail. Let's just see. Maybe my other command has lost its connectivity. Let's see if we have better luck over here. Yeah. Who knows? So that is now tailing the logs, and maybe this. What I'm going to let's see. Maybe that's going to work as well. So what I can then do is I can do the SAM remote invoke, or I can even do a AWS Lambda invoke, and I'm going to do that over there. And so this is going to invoke that function that I had using the CLI. I could have used the SAM remote invoke as well. It's come back, and now what I'm going to see is this log thing is going to update with what is happening.
I think the invoke failed.
Oh, there we go. No, there it is. I've actually got my name, my Julian. So that has actually come.
Okay.
If I was to then try it with name mesh, so that's going to invoke the Lambda function in the cloud, and the SAM logs is then going to pull that from when it eventually happens. Invoke results.
For some reason, it's not working. I don't know why.
No, I think it is actually working. Or am I going nuts?
It's the invoke failed for some reason. I don't know why.
Do you know why? Because I'm not. That's probably why. Anyway, so anyway, that will come back with another invoke. So the thing is, you can sit here, and also what you can do is X-ray. So if you do have, you can also do the SAM logs and the traces, and then in another terminal, you can just have the logs running, and so you can test locally, test your integrations in the cloud, and your Lambda logs are just streaming from CloudWatch logs. And it's a similar functionality in the CloudWatch console, where you can just stream the logs. Super useful. So that's something that people don't necessarily know about that. And then, also if you want to delete this, I can just do SAM delete, and it's going to delete that whole CloudFormation stack, and I'm done. So, yeah, bit of a whirlwind tour of sort of Lambda and containers.
That was fun.
The demo sort of made kind of things. I managed to disappear off the screen once or twice. So yeah, it's been one of one of those.
I mean, if it would have gone smoothly, it wouldn't have been fun. I mean,
too slick, exactly.
True.
Too slick, yeah.
Exactly.
Yeah. So I mean, the thing is, this merging of the two worlds, I think, is really cool, and I love being able to use the Docker tools I know and do Docker files and just be able to, and then run a Lambda function. So the Docker file is exactly what people understand. Nothing clever. It's a normal JavaScript or Python or any kind of thing. You install any dependencies that can be up to 10 gig. And then this cool thing is you deploy that into the cloud and off it goes.
Yeah. That was awesome. Quick, but awesome. And that's why I'm saying if anybody wanted to get back, of course, you can catch the recording, of course, after the episode.
Yeah.
I want to thank everybody, of course, which was joining us on the live stream. All the questions from Juan, from Benno, from who else was here? From Kavion, from Hatif, from Fear, and from Tarun. Thank you very much for participating in your in the chat. It was very appreciated. Hope to see you back again on our future shows. I do want to give you a plug. You say you have your serverless office hours also streamed on Twitch. Can you and on YouTube? Can you tell me how our customers and viewers can find you?
Yes, we can. So that is youtube.com/serverlessland. And that is, that's the YouTube one. It's also on Twitch with AWS. And that is at 10 a.m. Pacific time for our Seattle-based friends. I'm in London, so it is 6 p.m. If you are in Central European time, that'll be 7 p.m. And that's every week at that time on a Tuesday. So Tuesdays at 10 a.m. Pacific. And because it's serverless office hours, it's actually really broad. We've had some cool AI stuff recently. We sometimes do, best practices for Java. Next week, we're talking all about Confluent and Kafka, actually, funny enough. We've got, it's really broad. We talk about, new features. We get AWS Serverless Heroes coming and talking on the crazy things they're building in the cloud. So that's on. And there's also another whole site called serverlessland.com. And that's a great resource for everything to do with serverless on AWS. There's a lot of things all about the individual services, but you can actually, if you click on the Learn page and you go to guides, there's some really in-depth guides on learning about Lambda, learning about serverless. In fact, there's also a guide called a video series called Lambda Fundamentals. So if you call AWS Lambda Fundamentals, it's on YouTube. I think 23 videos going through all of the things that Lambda works. And so that's a good way that you can hopefully get into that. And then the second part of it as well is lots of code. So we talked about infrastructure as code. Lambda is all about running your code in the cloud. And so serverlessland.com/patterns is a huge resource of hundreds. I think over 700 infrastructure as code patterns across all languages, CDK, Terraform, Python, Pulumi. And so you can build really cool applications with Lambda. And these are just literally, it's a GitHub repo. It's open source. You can, contribute as well. And you can build so many little mini microservices that are all there, some of them big as well. And so, you want to use Lambda with API Gateway or with ECS or, all these kind of things. It's all there.
Awesome. Julian, thank you very much for the whirlwind tour. And thank you very much, everybody, for listening and joining in. Please don't forget to subscribe to our YouTube channel. Hit that subscribe button that you get a notification when we have the next stream. We will be back again on Containers on the Couch next week, same time, which is 12 o'clock Pacific on a Thursday. Next week will be an EKS episode, and the week afterwards we'll be back again with another new episode on ECS. Thank you all for joining, and thank you very much, Julian, for an amazing episode.
Pleasure. Thanks for having me, Vaish.
Thanks a lot. Have a good day, everybody.
Bye-bye.
Bye.